I'm going to teach you how to do the problems on this assignment, which is on September 30th, Mass Conservation Part B. So we have these two documents. The first one, it says mass conservation reactions, and the other one is the law of mass conservation. So these are two different documents that are coming up. So I would suggest you to do this one first because it's pretty basic, and then once we are done with this, then you move on to the mass conservation of reactants, right? Reactions, sorry. So now before I teach you how to work on these assignments, I want to teach you about this law. So there is this material on the Google Classroom in the classwork. It says matter and properties study guide. So you go to the study guide and open up the PDF file, and you scroll all the way to page 45. I did not download it. I just one click and you can actually view the presentation. It doesn't take away space on your computer or anything. So you are on page 45. So it says law of conservation of mass. So it says over here, you see a scale that reads 100 grams. This is unburned coal. And after you burn it, you're left with ash. This is the right hand side, a little bit of ash and a lot of smoke. We are not letting the smoke escape because we have covered it with the glass jar. And now the reading of this scale says 100 grams again. So mass before burning equals the mass after burning. This is what the law of mass conservation is. It says that the mass cannot be created or destroyed, it is only transformed into something else. So here the mass of the unburnt coal is transformed into fumes and gas and ash, and together everything adds up to 100, which is the same as before. So the mass is conserved. All right, so this is the mass and this is the scientist who gave this law. This is very similar to the conservation of energy, which also states energy cannot be created or destroyed. It can only be transformed from one form to another. Okay, so if we move on, let's see another example. We have two scales. One of them has the reading of the mass 43.43 with two glass bottles. We call them vials, viles, vials, which have the cap on them. These two vials with colorless liquid. This is before they are mixed together, and on the right hand side the scale reads the same value of mass. So the mass is same before and after mixing. And this is also the evidence of a chemical change, because when you mix these two liquids there is a color change. Color change is the evidence for a chemical change. And this is a closed system because we have the caps on. System is a place where you are doing a reaction. That is a system. So if we open the caps or the containers or the vials, then it will be an open system. So the mass is conserved in all the cases, but you will not be able to see it in a open system, okay, because we let the gases escape. So this is an example of mass conservation. Before mass equals the after mass. Okay, and this is a question, and here we have the balance scale. Abby is one person and Jane is the other. Abby has water and sugar on the scale. Jane has water and sugar on the scale, the same amount of water and sugar. What Jane does is Jane takes her glass of water off the scale and pours her sugar into her glass. She stirs it until she cannot see the sugar granules anymore. So she mixes the water and sugar. Abby leaves the glass as is and the sugar as is. So now you are asked to sketch what you think the scales will look like if Jane puts her glass and sugar back on the scale. Explain your answer. So what they are trying to ask is, after Jane mixes the water and sugar until all the sugar is gone, she puts the container back, both of them back, the empty sugar and the water with sugar in it. Will the scale be the same as Abby's? Abby did not do anything new. So although the two things are mixed, the mass before and after will be the same. It's a physical change because you're dissolving everything. So in a physical change also, the mass will be the same as the Abby's. Although it's an open system, we can let the gases escape, but this particular dissolving does not have any gases released, so the mass will be the same as before, as Abby's. Jane and Abby will have the same mass reading. This is a law of mass conservation. One more example, this is a candle before burning and after burning. The question is, will the mass be same although there is a equal to sign? Yes, the mass will be the same, but if you put it on a scale, it will not show same because you have let the smoke and the gas escape. If you let that happen, then the scale will not read it, but the mass conservation happened. The extra mass got transformed into smoke and gas. So that's a law of mass conservation.